basic counting principle. Suppose one event can be chosen in n different ways, and other independent event can be chosen in q different ways, then two events can be chosen in p times q ways. So you multiply them. So how many ways can you choose? Choose 6 green, 5 orange, 10 purple, 4 red, and 7 yellow beans out of a jar. It's going to be 6 times 5 times 10 times 4 times 7. What do you get? 8,400 different ways. Did you plug into the calculator? How did you get that number? How did you get that number so quick? Is it right? Guys, please take out your calculator. Is it right? None of you checked it? 6 times 5 times 10 times 4 times 7. What about here? How many outfits can be made with 5 pairs of pants, 8 shirts, and 3 pairs of shoes? So how many different events? Shirts, pants, and shoes, right? So 5 pairs and 8 shirts and 3 pairs of shoes. How many total outfits? 120 outfits. How many of you guys have more than 5 pairs of pants? I'm sure most of you. 8 shirts? More than 8 shirts? I'm sure you do. 3 pairs of shoes? That means what? That means what? I only saw you for like 80 days this semester. That means every time I see you, you should be in a different profit. But a lot of you...
I wear the same thing every day.
Yeah, I see you guys wearing same thing most of the days, guys. Be creative, stylish, guys. Come on. Permutation is when the order matters. And how do you, so it's the arrangement of objects in a certain order called permutation. And again, the order matters for that case. I'll let you know when the order doesn't matter. That's for combination, and I'll show you the difference in a second. And here's the formula that you can use to find the total number of outcomes for permutation. So it's n, the total number, factorial, divided by n minus r factorials. Okay, I'll get back to this formula with the example on the next page. So here, there are 10 names on the bullet for senior class officers. 4 will be selected to form a class committee. In how many ways can a committee of 4 be formed if each student have different roles, different responsibilities? So for this case, does the order matter or not? So if you're going to pick 4 out of 10, but this is what? President, vice president, treasurer, secretary. So would this matter? Would the order of picking 4 matter or not?
Yes.
One being a president is different than that person being a vice president, right? So for this case, the order matters, so we use permutation. And how many are we choosing from? 10. We're choosing 4 from 10. So for the president, how many possible outcomes can we have? 10. We can choose out of 10. Now, 1 is already selected as president. Now, how many students can be chosen for vice president? 9, then 8, and 7. This is permutation. So if you use this formula right here, 10 factorial divided by 10 minus, how many are we choosing? 4. So 6 factorial is this. Why? What is 10 factorial? Guys, do you guys remember? 10 factorial means 10 factorial means it's the product of every number from 10 and until it gets to 1. You decrease it by 1. So it is, I'll write it here, 10 times, 9 times, 8 times, 7 times, 6 times, 5, 4, 3, 2, 1. But a lot of times we don't write 1 because multiplying by 1 is same as itself. And we are dividing by 10 minus 4, which is 6 factorial. So that is 6, 5, 4, 3, 2, 1. So you see what happens? These get canceled out, right? They become 1s. 6 divided by 6 become 1. They cancel out, cancel out. So you end up getting 10 times 9 times 8 times 7, which we got from here. Okay? So what is that? What is 10 times 9 times 8 times 7? 50. 40 different ways is your answer. And let me show you how you can use a calculator to do this. So first, factorial. So what are we doing? We do 10 factorial. You go to the math. And guess where we are going? To the probability. And you see number 4, there's a factorial. And what are we doing? We divide it by what? 6 factorials. Guys, please take out your calculator and try this. 6 factorial. So you go to the math, probability, and number 4 factorial. And that's what you get. Another thing that you can use, but make sure you know how to do this by hand, okay? But if you want to do the permutation, you can put 10 first and go to math, probability again. You see NPR, N picking R for permutation, and choosing R for combination. So you go pick number 2, permutation, and how many were we picking from 10? 4, 1040. Okay. Let's look at this example question. You have homework assignment from 5 different classes to complete tonight. How many different ways can you complete the assignments? How many ways? So how many events we have? 5 classes. And how many? So for the first homework, how many do you have to choose from? 5. So now you're done with 1. For the second homework that you're going to do, how many choices you have? 4, 3, 2, 1, right? So what is that? How many different ways you have? 20 times 6, which is 120. And how many different ways can you choose 2 of the assignment to complete first or second? So now we're picking only 2 homeworks. So would it be different to do math homework first and English versus English first and math? Yes, right? It's a different order. So it is permutation. So it becomes 5 times 4. Why? Because you're picking 2 from 5. So it's permutation. Do you see why the order matters? So then what is this? It's 5 factorial divided by 5 minus 2 factorial, which is 5, 4, 3, 2, 1. And 3 factorial is 3, 2, 1. So you get 20. 20 ways. So if we check our answer on the calculator, it's 5 picking permutation. 2, you get 20 different ways. So when you have 5 homeworks, if you just want to know how many different ways to do the homework, there are 20 different ways to choose from. It's all about making choices, guys. Isn't it exciting? Don't you usually get 5 homeworks a day? There are 120 different ways to do the homework. How exciting, guys. It's all about choices. And here's a permutation that's called distinguishable permutation. So here, what happens is, let's look at an example. There are 9 letters. And we want to form a word. It doesn't have to really have a meaning, but we want to know how many different words that we can come up with. So it's going to be what? 9 times 8 times 7, 6, 5, 4, 3, 2, 1, right? So for the first letter, you have 9 to choose from. Once you use 1, now you have 8 to choose from, 7 to choose from, and so on. So what do you get? That is 9 factorials, probability. So that is 362,880. 362 and 880 words. Okay? So with 9 letters, you can come up with 362,880 words. Isn't that amazing? That's why the state, license plate has only 3 letters and 3 words, but it covers the whole population in Maryland who has cars. Didn't you ever wonder how we can all have different plates with only 6 numbers? Yeah. This is why it's making it possible. But here, look at this. Butterfly, it's still 9 words, but think about it. Would this T, the first T going to the second T, and second T going to the first T make a different word? No, it's still butterfly. Then, what happens? If the number letter is repeated to make the same result, you have to divide by the number of time it repeated factorial from whatever you got. So here, what you're doing is 9 factorial divided by what? How many t's do we have? 2. So you do 2 factorial. Meaning, 2 factorial is what? Half, right? 2 times 1. So it's only half of this, which will be 181,440. 181,440 words. These are called distinguishable permutation. The order still matters, but there's some that will not change the outcome. Yes? Factorials. It's a product of number that you multiply until that number becomes 1. You decrease it by 1. What about bumblebee? So it's 9 letters again, divided by, is there any letter repeated? B, B, B. So now you divide by 3 factorials. E, 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 3 factorials. Is there anything else? No. So this time you do 9 factorial divided by, what's 3 factorial, guys? 3 times 2 times 1. So this is 6, and this is also 6. So can I just divide it by 36? Or I'll do divide by 6 and 6. If you want to just divide it once, make sure you put the parentheses. So now it is 10,080 words. It was permutation, but they are called distinguishable permutations. That's what I did. Yeah, divide by 6 twice. That means divide by 36. So last type is combination. Combination is when the order does not matter. So for example, if you have 10 toppings to choose from when you order a pizza and you're choosing 3, does it matter whether they put sausage, pepperoni, and pepper versus putting pepperoni, sausage, and pepper? You see what I mean? So does the order matter? If your mom order in a different way, does that mean you're going to get different pizza? No. So those types are called combination because the order does not matter. Do you guys see the difference? Permutation, the order matters. But combination, order does not matter. So then, what you need to do, there will be less outcome with combinations. So you divide it by r factorial again. That's the difference, okay? So let's look at an example. So here, permutation means the order matters, right? So is getting E and F different than getting F and E? Hope no one gets failed and E, but you see how they're different? They're counted as 2. But combination, again, the order doesn't matter. So EF is same as FE. So we just count it as 1, so you get only half of what you're getting here. Why? Because you have to divide by, when you're choosing 2, you have to divide by 2 factorials again for combination. Do you guys see the difference between permutation and combination? Combination, order does not matter. Permutation, it does matter. So what about this one? At Grant High School, there are 15 names on the ballot for junior class officers, and 5 are selected to form a class committee. Just 5 are chosen for the committee. Does the order matter? No, they don't have different rules, so it doesn't matter if I choose you first versus her, because it's just 5 total. They don't have different rules. So this is combination. So what do we do? It is 15. Now you can say combination 5 or 15 choosing 5, which is 15 factorial divided by 15 minus 5 factorial divided by what? 5 factorials again. No, this number. It was 2 from the previous question. That's why we did 2 factorial. This one we're choosing 5, so you have to divide by 5 factorials. So first, let me show you how to do this by hand. Guys, write this down. So 15 factorial is 15 times 14, 13, 12, 11, 10, 9, dot, 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 dot. I'm going to just write dots. Why? What is 15 minus 5 factorial? Isn't that 10 times 9 times 8 times dot, dot, dot? That means these are all gone. You see it? Now I have 5 factorials left. So I can put 5, 4, 3, 2, 1. You don't have to write 1. So here you can do it by hand. What's 15 divided by 5? 3. What's 3 divided by 3? Gone. What's 14 divided by 2? 7. What's 12 divided by 4? 3. So you're just doing what? 7 times 13 times 3 times 11. Right? So make sure you know how to solve these by hands. So what was it? It was 7 times 13 times 3 times 11. 3003. 3003 different ways, different committees, right? So let's just use a calculator to do 15 choosing 5. 15 math probability. Now it's 3.
You got 3,003 ways?
Yes.
How? Wasn't it 3 times 7 times 13 times 3?
7 times 13 times 3 times 11.
Oh, times 11.
Yeah. So you see how you can easily use the combination? So now here, how many ways can a committee of 5 be formed if each student have different responsibility? So would the order matter? Yes, right? One choosing for president, again, is different than choosing that person as a vice president. So this will be what? 15 permutation 5, which is 15 factorial divided by 10 factorial. So you get 15, 14, 13, 12, 11, 10, dot, dot, dot. And 10 factorial is what? 10, dot, dot, dot. So it's just these numbers multiply. Or just plug into the calculator, 15 math probability and permutation choosing 5. You get 360,360. 360,360 different committees, right? You get more for permutations. Oh, last one. So again, at the same high school, there are 15 names on the bullet for junior officers. 5 will be selected to form a class committee, okay? But the question is, if there are 8 girls and 7 boys on the bullet, how many committees of 2 boys and 3 girls can be formed? So first, let's find how many ways can 2 boys be chosen from 7. Does the order matter? No. They're just choosing the committees, right? So how many can be chosen from 7 to 2? You're choosing 2 from 7. Order doesn't matter, so it's combination. So what do you get? Just plug into the calculator. So 7 math probability choosing 2. Wait. The order doesn't matter, so it should be combination. 7 math. 2, yes. So you get 21. How many ways can 3 girls chosen from 8? So 8 choosing 3. 8 math probability choosing 3. So you get 56. So now, that wasn't the question, right? The question was how many ways 2 boys and 3 girls can be chosen together. Now, what do you do with these 2? Multiply. Now, it comes back to the basic counting principle. There are 2 events, boys and girls, and there are 21 outcomes for boys and 56 for girls. So the total different ways of choosing 2 boys and 3 girls will be 21 times 56. So this is a little more advanced than the ones that we did, but because you have to use combinations and then multiply them by using the basic counting principle.